In this video, I'm going to explain the critical value approach. We've gone through the p-value approach, for which you use your calculator. You can use calculator to determine the p-value. However, I'm going to show you the critical value, but as I said, on the test, I won't require to use one method or another. You can, if you feel comfortable with the p-value method, that's fine. If some of you would like to use this method that I'm going to explain right now, it's also fine. The p-value approach works the following way. You find the p-value, which is a probability, and then you have alpha, which is another probability. You compare the two values. If the p-value is less than alpha, you reject HO. If the p-value is more than alpha, you fail to reject HO. Now let me show you how the critical value approach works. I just made up an example. So let's say we have this example: mu less than or equal to 15 and the null greater than 15. This is the claim. N is 31, sigma is 2.75, population standard deviation, x bar is 16.32, and alpha equals 0.05. So this is the first step. We state the null and the alternative. The second step, you can do it either by hand or using the calculator, which is find the test statistic, which is x bar minus mu divided by sigma over square root of n. If you guys want to do the math, it will be x bar, which is 16.32, minus 15, which we assume the null hypothesis is true until proven otherwise. Sigma is 2.75 divided by square root of n, which is square root of 31. Okay, I'm going to save time. Bring the calculator. I already input the data in there. And I'm just going to get the z value from the calculator, not the p-value, because I'm showing you a different way of doing this. So the answer will be 2.67. That's all I need. Okay. Now let me explain to you how to find the critical value. Okay. This is a right tail test. So if there is a rejection region where you reject the null hypothesis, it will be on the right. If you have a left tail test, the rejection region where you reject the null hypothesis is on the left. And if it is a two-tail test, the rejection region will be on both tails of the normal curve. So we have alpha. Here's how you find the critical value. Please pay attention to this. Alpha is 0.05. Since this is a right tail test, you shade toward the end, and this is your alpha, equals 0.05, because alpha is the probability of rejecting the null hypothesis when it is actually true. When you make a mistake, it's a probability of neglecting something that is true. Now this is your 5% right here. The value right here, this is your critical value. So this is the border. This is the border value between the rejection region and the non-rejection region. This is the non-rejection region. Rejection of what? Rejection of HO. Of HO or H naught. This is the rejection region, guys. Okay. I need to find this value. You already learned in chapter 5 in the normal distribution chapter how to find, this value. This is inverse norm. Okay, I need the area to the left. By default, we need the area to the left. Since the area to the right is 5%, the area to the left will be what? 0.95. And then the mean is 0 and the standard deviation is 1. Even if you guys put 0.05 here, that is okay, but you're going to get a negative number. But our z, our critical value is not negative because it's toward the right, so just change the sign. So if I do this, let me show you, remind you how to do that. So you just go to second, distribute, inverse norm, 0.95, comma 0, comma 1, paste, and here you go, it's 1.645. So instead of the p-value, this is step number 3. So that's step number 1. Step number 2, Now step number 3, you found the critical value, which is 1.645. Now how do you make a decision to reject HO or fail to reject the null hypothesis? Here's how you do it, guys. It's very simple. In step number 2, you found the test statistic to be 2.67. All I want you to do, just place 2.67 on this number line. Well, if you try to place 2.67 on this number line, you know that it's going to be bigger than 1.645, so it will be somewhere here, if you agree with me. So 2.67. And you also notice that it turned out to be in the rejection region, in the shaded region. So what's your decision will be here? Reject HO. So all you have to do, once you find the critical value, go back to step number 2 and put it on the number line. If this number turns out to be in the rejection region, you say I reject HO. If this number turns out not to be in the rejection region, you say I fail to reject HO, and you proceed from there. And step number 5 will be, there is enough evidence at the 0.05 level of significance to support the claim. Whatever the claim is, you just write it down, that blah blah blah. So this is how it works. Now I'm going to show you another example with the left tail test. So that was the right tail test. Here's another example with the left tail test. Example 2, HO. I'm just going to make up stuff again just to explain that to you. So let's say more than 10, mu is less than 10. This is the claim. Let's say I'm going to make up n is 25. Sigma is 1.22. X bar is 9.12. And alpha, let's make it 0.05 again. Okay. And so the first step, I already put that. Second step is to find the test statistic. You can either use it by hand or using the calculator, which is going to be here, what, 9.12 minus 10 divided by sigma 1.22 divided by square root of 25. And let's use the calculator to do this. I'm going to run the test. Stat, tests, z-test. Why z-test? Because sigma is giving. When sigma is not given, we go to t-test. So mu 0 is 10. Let me just make sure of the values. Sigma is 1.22. X bar is 9.12. And I made it 25. And what would be the sign here? The alternative sign, the sign in the alternative hypothesis is less than. All right. And then calculate negative 3.61. Again, don't look at the p-value because I'm using the different way now. So negative 3.61. Okay. Number 3, critical value. Watch. You do the curve. Okay, you agree with me that this is a left tail test because the sign in the alternative is less than, so your rejection region is going to be on the left. And what is alpha here? So this area, guys, is alpha 5%. You need to find this value right here, ZC. They call it ZC, which is the critical value. Z for C, C critical, or Z sub 0 in the book. How do I find it? Inverse norm. Okay, what is the area to the left? Well, which is 0.05, 0.1. And if you run the math, it's going to be the same as the previous example, but negative. So it's negative 1.645. So this is negative 1.645. Let's bring negative 3.61 down there. Well, you guys agree that negative 3.61 is going to be to the left of negative 1.6, somewhere here. Just put it anywhere, but to the left. Well, do you agree with me that this falls in the rejection region again? So what's the decision? Reject HO. And then step number 5 will be there is not enough there is enough evidence at the 0.05 level of significance to support the claim. Now I'm going to show you an example on how to find the critical value when you have a two-tailed test. Okay, so let's make one up. Okay, example 3. Let's say I'll make this up. HOHA mu equals 50, mu not equal 50. I'm gonna put the claim here in the null hypothesis this time. It could be in the null, it doesn't have to be always in the alternative. Okay, let's say, and then you got the data. So let's say n is 45. Let's say x bar is 50.75. Let's say sigma, we're still assuming population standard deviation, so is known, so it's a z-test. Let's say sigma is 0.78, and let's say alpha is, I'll make it 5%. I'll leave it as a 5%. Okay, so how do you proceed? Step number 1 we're already done. Step number 2 will be z equals x bar minus mu divided by sigma over square root of n, which is 50.75 minus. You always pick up the value from mu from the null hypothesis, assume it is true until proven otherwise, over 0.78 divided by square root of 45. Again, guys, if you don't want to do the math, that's okay. I'm going to use the calculator for the test. Tests, z-test, 50. Sigma is, I said, 0.78. X bar, what did I say, 50.75. And n I said 45, and I choose different from, then calculate. Okay, so z is 6.45 as you can see, and if you see the e negative 10 for a p-value, that means the p-value is so small it's almost 0, but we're not using the p-value approach now. I'm using the critical value, so I'm going to put 6.45 in there. Okay, step number 3, using critical values. You draw the curve. You put a 0 here in the center. And now alpha. Alpha is 0.05, but it's a two-tailed test, so we're going to split that 0.05 on both sides. So what would that be? That would be 0.025, and this one will be here 0.025. It's enough, guys, to find one critical value. The other one will be opposite in sign. I'm going to find this one, which is the easy one. It will be inverse norm, 0.025 area to the left, and then comma 0, comma 1. Okay, I think this is going to be negative 1.96. Let me show you. Second, distribute, inverse norm, 0.025, 0.1. Watch, negative 1.96. So we have two rejection region, guys, here, and the ZC here will be what? 1.96. And where is my test statistic? My test statistic, which is number 2, is 6.45. Well, you guys, you agree with me that the 6.45 should be way toward the right, so right here. And then what do you end up doing? I didn't intend to reject HO in all times, but it turned out that we end up rejecting HO. So reject HO. But the claim is in HO. If you reject HO and the claim is in HO, you end up rejecting the claim. So you say there is enough evidence at the 0.05 level of significance to reject the claim. Significance to reject the claim. Okay. Now, so this would take care of section for the section where sigma is known. Now, when sigma is not known and you want to use the critical value, you still do the same thing, but instead of using inverse z to find the critical value, you will use what we call inverse t, which is, and then inverse t requires an area to the left and degrees of freedom. So you can do that, or you can use table 5, which I'm gonna create another video, show you how to create, how to find a critical value using the table. But for now, this is how to work with the critical values when sigma is known. When sigma is not known, for example, in this example, example 3, all you have to do, guys, we need the area to the left, which is 0.025. Let's say that was S, not sigma given. It's just 0.025 degrees of freedom, 45. You subtract 1, 44, and then you can get the critical value. It's very simple to use, and the table by itself is very easy to use. So I hope this helps. But again, you guys, you have the freedom on the test to choose between the p-value and the critical value approach.